All right, we're live, guys.
15 questions. I'll start. In the pie chart, why are the slices sectors different sizes?
Each slice represents a category, and the area of each slice represents the portion of the total occupied by that category.
It's the second one. Yeah.
Yeah.
Yep, I agree.
I agree. How are bar charts and Pareto charts related? I haven't heard of a Pareto chart. Was that in?
So a Pareto chart is a bar chart, but it's ordered from largest to smallest.
Okay.
So it's basically the bars are lined up in the sequence from biggest to smallest, left to right.
Okay. So let's see then.
Yeah.
Who wants to read 5?
I'll go ahead. So we conclude that P is normally distributed if n times P is greater than or equal to 10, right? Those are the requirements. If P is the true proportion, is P the true proportion or the sample proportion?
So in the reading, if I remember correctly,
I want to say it's the sample.
let me just double check that though.
Yeah, for sure. Yeah, I'm not 100% on that.
That's the thing, dude. Like I always think I'm like, oh yeah, it's definitely this, and then I'm totally wrong.
Yeah, that's how stats goes usually.
I think number 6 is A. What is N?
Yeah, sample size.
Sample size.
Yeah, that's for sure.
Okay, so yeah, that's what I was thinking. All right, number 6. It says, "What is?" Oh wait, sorry. Were you saying 6 is N or is?
6 is A.
Okay.
6 is A, yeah.
We haven't determined what 5 is yet.
I'm guessing that P is the sample proportion. I'm looking it up still right now though.
Okay. I'll get started on 7. It's just plugging in the p-value in those equations from question 5. So I guess we can take a look at that.
Okay, go ahead. Yeah, it's P hat is sample proportion.
Okay.
It says the sample proportion P hat is normally distributed if N is large, and then the true population mean of the random. Okay, yeah. So yeah, it's sample proportion.
Okay. On number 7, I got 40. If you plug the p-value into the equation, n times p is greater than or equal to 10. Just by dividing 10 by p, you can get n. Comes out, so 10 divided by 0.25 is 40, which is greater than that. But I guess
that makes sense to me too. That's correct.
So
okay.
The smallest number N can be is 40 then, huh?
Well, I guess let me try it on the other equation really quick. So 1 minus 1.25.
So 0.75 times by 40, which is 30, and 30 is greater than or equal to 10.
And then when you plug p into the second equation, because you have to verify both, you get n equals 13.3, which is not a clean number. I don't know if that makes a difference, but
1 second.
what do you guys think? I'm just trying to plug them in and see what.
Yeah. Let's see.
Yeah, I think it's 40.
Okay.
That's what I'm getting.
Yeah.
Okay.
Makes sense.
It's a clean number.
Alright, so let's use the following information to answer the questions 8 and 9. Suppose n is 24 and p-value or p is 0.4. What is the mean of p hat?
0.4.
Oh
The
yeah,
mean?
it said when let's see.
Yeah, it's 24.
Yeah, the mean of p hat is p. Yep.
Yeah.
Nice. All right, then what is the standard deviation of p hat? We just define that. We just take. Here, I'll screen share. I have it pulled up right here. So we just take p times by 1 minus p divided by n, square root the whole thing. If someone wants to plug and chug.
I'm getting 0.1. That all? We want to double check that?
Yeah, does someone want to double check?
Yeah, I'm trying to see that equation. Will you read it to me? I can't really read it.
Oh yeah, it's maybe if I zoom in.
Yeah, there you
No,
go.
I can't see anything. I can't on your screen share.
P hat equals p times. Okay.
Well, isn't it? It's p the square root of p, and then in parentheses p minus 1 divided by n.
1 minus p, not p minus 1.
Yeah, 1 minus p.
And you have to be sure to square root the whole thing. So you have to find your denominator and numerator, and then square root the whole thing after that. Um, 24.
What did you get, Josh?
I got 0.1.
Yeah, that's what I'm getting.
Okay. Cool.
Yeah, that's what I got too. 0.1. All right.
You want me to read 10?
Go for it.
Use the following information to answer questions 10 through 13. Brittany's batting average is .300. We want to determine the possibility that she will get more than 35 hits in her next 100 times at bat. N equals 100 and P equals .03. What is P hat? Rounded to decimal. That's pretty easy.
Would it still just be the 0.30?
0.30, right?
Yeah.
Because it'll equal mean of p.
Is it 100?
And then we just have to plug that into the standard deviation of p hat equation.
Yeah.
Okay.
So 0.3.
0.3 times by 0.7 on the top, and then divide
Divide by 100, right?
Yeah, divide by 100, then square root it.
Square root it. 0.0458.
Yeah, that's what I got.
0.045.
0.04, or we're just going to 3. Oh, 3 this one. 0.046.
0.046.
Yep. Then z-score. Let me see if there's something different on z-score. Okay, so for z-score, this will be easy enough because we already have the standard deviation. You take p hat minus p, and then divide it by the standard deviation.
So it's you take her her batting average she hopes to get minus 0.3.
Oh no, it's the same number.
Because at 35 into 100 is 0.35.
Well, so you would just take p. You just take p minus p hat. I'm sorry, p hat minus p. And then,
Isn't that the same number?
yeah, and it's the same number. So we have a 0 on the top. So would it just be 0?
I
That
I
doesn't
think
make
you take do you have the equation for z-score from that chapter?
I'll
we
screen share again.
screen share, yeah.
Let's take a look at it. Because there's an example of this, like I think towards the bottom
Right here.
of
So
the
to
yeah.
define z-score, you just take the value, the p hat
Okay.
minus the mean, which is p. and
So
divide
it is
by the deviation.
p hat 0.35 because that is the I guess it says she wants to get 35 out of 100 at bats. So that's the
Oh.
number in question is 0.35.
Oh, okay. Sorry, I was just looking at the 0.3. I was just looking at this number right here.
Yeah.
Okay, so it's
You take 0.35 minus the mean.
okay, that works. So 0.35 minus 0.3 divided by this number.
Divided by 0.046.
Yeah.
Wait, so are we changing number 10 with that?
No, p hat's right.
So 10 is 0.046 still.
Well,
Uh,
p hat.
Yeah, I think so. I think we're right.
So we'll stick with 0.3.
Yeah, but then on number
But
12,
we'll
you're just taking the 35 hits into, I think, I don't know.
would it be the
It's
0.3?
it's 35%, so it's 0.35, right? Is if we're doing, you know.
Yeah, that's what we're doing.
Well,
But so wouldn't it be 0.3 minus 0.35? So we would have
yeah, you're gonna get a negative z-score. But here's the problem with that is you want to know the probability that she'll get more than 35 hits, not less than. So I think the z-score's got to be positive, right?
No, I think the z-score is negative because
it's negative.
her average is 30%, and we're looking for 35.
Oh, okay. Oh, right. Okay. So it'll be a negative number.
Yeah.
Because it'll be everything above that point on the, like if you were to put it in the applet, like everything above that point.
Oh, yeah.
Tail.
Okay.
So it's negative 1.087. Is that what you got?
Yeah.
Sweet. That's what I got too.
That was.
Wait.
If we do just go to the applet.
Well, I plugged it in and got 0.8615 as the area.
All right.
If it's everything above that z-score. It has an 86% chance of getting that.
Yeah, I got 86. Or yeah,
So 0.862 or something like that.
Yeah, 0.8615.
Okay.
So 0.862.
What did you get? What was the z-score on that? Sorry.
The z-score, I'm still screen sharing. It's negative 1.087.
Okay, thank you.
Yeah. And then from the applet, we got 0.862.
Okay.
Wait. Number 13. Or sorry, 14.
I can read that. So if it says if the true proportion of people who support a political candidate is P equals 0.52, and if N equals 2,000 people are surveyed, we want to determine the probability that the results of the survey will suggest the candidate is losing the election or getting less than 50% of the votes. Find the standard deviation of P hat.
Okay.
And just plug and chug.
Yeah, same equation.
So just 0.5 minus 0.52. Oh, wait. Standard deviation.
Divided by 2,000.
Yeah, divided by 2,000, then
Square root.
I'm getting 0.01. Well, I guess to 3 places it would be 0.011.
Okay.
How about you guys?
Let me see real quick.
Still doing it.
Okay. 0. I think I did that right.
Wait, so on the standard deviation, how do we do that again? Okay, it's just p times.
We're using p equals 0.52, right?
Yeah.
Yeah.
So 0.5.
Okay. Okay. Cool.
Yeah, I got 0.011.
Yep.
0.011. Okay.
Yep.
Sweet.
And then what z-score would you use? Oh, for that one we would just do let's see, p hat minus p. Okay, so it'd be 0.5 minus 0.52
Yeah, and then divided by the 0.011.
divided by. I got negative 1.818 heating.
Same here.
8.
So I just measured 1.818.
Yep.
Jason, are you still good on that?
You guys are going a little fast for me.
You were being quiet, so I figured something was wrong. Where are you at, Jason?
Well, I've got. So anyway, you know, my brain's not working that well. So I had a hard day. But,
We haven't even working on it. So let's go back to wherever you are, and let's work through it.
so 10 is 0.03.
0.30.
Yeah.
30.
Mm-hmm.
Need to work these out.
That again is just going to be the
Just the p-value.
yeah.
Just it's the
Okay, and you have to have the trailing 0, 2 decimals.
Yeah. 3.
Yep. Right.
11 is 0.046.
Yes.
12 is negative 1.087.
Yeah.
13, 0.35.
It's actually 0.862.
Oh.
Yep.
86.
So I have a question on that one. It
Yeah.
just doesn't make sense. I mean, the equation, I did the equation, but reading the question, her average is 30%. The probability of her getting 35 hits is 86%. I don't understand that.
Well, because so think about it. So she has a 30% hitting average, right?
Okay.
So in the next 100 at bat she gets, she has an 86% chance of getting at least 35.
So when you plug the z-score into the applet, you want to shade the area to the right of negative 1.087,
Okay.
and that'll give you the area of 0.8615.
Does that make sense though, Kelly? Because like if it said at least 30% of her hits, it would be 100%. Because she has an average batting average of 3.
Okay.
So that means every 100 at bat she's going to get at least 30 hits.
So okay, I understand now. Thanks.
Yeah.
So she's improving her batting average.
She has a chance, 86% chance of doing so.
Yeah, she has a chance of getting 35 instead of 30.
Okay. At 14, we've got 0.011.
Mm-hmm.
Yep.
15 is negative 0.0818.
Negative 1.818.
Yeah, I got negative 1.818 as well.
Yeah, that's what I got.
18.
Number 16, we ready to move on?
Sure.
Okay, what probability do you compute using the normal probability applet? What's the big Z? It's the big...
I've never seen that. Is that in the reading?
it must
That
be.
symbol?
Do it.
Gotta be.
Start reading. Come on.
I don't have the reading up. Do you guys have the book up? Sorry, I don't have my book up. Oh, you're screen sharing.
Hold it up.
I'm not seeing. I don't remember this from the reading.
I don't either. Never seen the
Is
big
it
Z.
less than or equal to the Z score? I don't know. Because we went to the left
This looks familiar.
of less than.
Those equations.
Do you shade to the left?
I don't remember it.
I don't know.
You don't remember?
Not off the top of my head.
We just have never seen that. None of us in my group have seen the big Z. I don't know what that is. Do you know what it is?
I don't know. I'm guessing.
Z is just Z score. Oh. Okay, thanks.
Yeah, that's really weird.
I'm almost done here.
I just searched the whole reading,
I
and
don't see it anywhere.
just like control find, and there isn't any big Z's. Like there's Z score all over, but there's no big Z.
Oh no, I'm good, thanks.
Because are we? I mean, I don't know what they mean, but if you're looking at the probability or the area, don't you shade to the left of the Z score, so it'd be less than or equal to Z?
Well, it depends on what you're trying to find using the Z score. Like,
Yeah.
testing.
All we can do is relate it to the previous problems that we have, although it doesn't say it's for that.
Yeah. Okay.
So
What probability you can? Oh yeah. I guess maybe this isn't related to.
it's probably just not a theory. It's probably just related to, 10. Question 10.
I would say that it's the first option.
Yeah, because it follows 14.
Cool. I'm good with that.
Yeah.
Try it, see what happens.
Number 17, what is the probability that the survey results will show the candidate is losing even though the true P is 0.52? So again, we just plug in that Z-score, and we select everything to the, I'm pretty sure to the right, or to the left.
Left.
Yeah,
To the left of the Z score. Yeah.
You're talking losing, so less than 50%.
Right, so everything to the left.
0.035, I think.
What is it?
What did you get? Sorry?
0.035.
Yeah,
What
that's
do
0.0345, so yeah, running up to 0.03.
Okay.
And you're just plugging in number 15, right?
Yeah.
Yep. So that helps us with number 16. Number 17 is still talking about number 14, so number 16 is obviously doing the same.
Okay. Cool.
So, ready to go? Everybody comfortable?
See what we got.
Well, if we're going off of 14, I'm guessing for 16 we want to go less than, because we're going to the left. Right?
Wait, say
So
what
you're saying 16's B then?
Yeah, because if we're saying like if if 16 is based off of 14, then we're looking at everything to the left of the z-score because it's everything less than.
Less than or equal
So it
to.
would be the second option because we're looking at everything to the left. Less than or equal to.
Oh, I think I agree with that.
Yeah, that's what would make sense for me on that one.
Less than. Yeah, because we're looking at the chance of loss, not winning.
Right. I'm guessing what Z, like the capital Z stands for, is just like the shaded area, because we plug in the Z-score, which is the little z. Or no,
Okay.
it is the shaded area, because that's the probability. I don't know what this big Z means.
It's a hard one.
Alright, let's see how we did.
Hey, really quick, I tried to submit. I didn't put 3 and 4 because I was still joining, like trying to pull it up. What did you guys get?
So 3 is B, and
Okay.
4 is C.
B and C. Thank you.
Mhm.
Okay, ready to go.
Ouch.
Yeah, I don't know what we did wrong, guys.
So I think the confusion. This is what was kind of weird on the homework was when you're like on number 10 and on number like 12, 13.
And
You have to understand like when you're finding the z-score, like what numbers to put in the numerator. I think that's where we're confused. That's where I'm confused. Like when you have the value minus the mean over this divided by the standard deviation.
Mhm.
Like I'm not sure what number is like. I don't know. I wonder if
I think we're messing up on the.
because we're getting the z-scores incorrect,
We're just getting
kind
the
of
standard deviation.
which affects the probability answers.
Right.
Isn't the numerator just the standard deviation?
No, to find the z-score according to the reading is it equals the value minus the mean over the standard deviation.
Yeah,
But I just don't know which numbers go where in the numerator.
that's what we were doing, though. That's what Kelly said, too. Like, the denominator is just the standard deviation.
Right.
Oh, sorry.
But the numerator, I don't know what to subtract from what, honestly.
Yeah, we might be backwards or something.
But
Yeah.
here's the crazy thing. So if we got 15 wrong, then how do we get 17 right?
Yeah.
Oh.
Because that one should correspond. Like
Should the z-score? Yeah, I guess.
Should it be positive?
Good point.
Or backward? No.
Because if you go
16.
beyond the positive number, it's the same. So maybe it's just positive, and I think the same goes for the number 12. Well, maybe not, because
you got 13 wrong.
yeah, exactly. Yeah.
I was so
Yeah.
confident in this, too. Like, I felt like I understood it.
Well, that was quick, at least tonight.
So I'm guessing p hat for 10 would be the 0.35. Because
Right.
so we got number 5 wrong because p is the true proportion, not the sample proportion, because sample proportion is p hat.
Okay.
And so
Gotcha.
the sample for number 10 would be 0.35, not 0.3.
Okay.
Dang it! Freaking heck.
Can't wait till this class is over.
We can redo this one because, like, I get what we did wrong now.
Yeah.
All right. Well, hey, good job today, guys.
Okay.
Yeah, that was
See you
quick.
guys.
Thanks. See ya.
Bye.
Yep.
All right.